Hello, good afternoon to all of you. I hope all of you are doing well. So, in today's class, we're going to discuss the rest of the concepts associated with object oriented programming. So, in the previous class, what we discussed is we have discussed some of the concepts related to object oriented programming. Okay, we discussed what is an object, right? We discussed the need for creating a resemblance between the real world entity and the logical object in the object oriented system. We discussed the reason why the concept of object has come into picture. We discussed that the object-oriented system is realized as a collection of interacting objects, right? We discussed that an object has data and the member functions. We discussed that the object interact with each other by passing messages. Okay, then we moved on to a class where we discussed what is the importance of the class, right? Okay, what is the composition of the class and why do we need to create a class? We discussed the way how we can instantiate objects from the class, and then we moved on to an important aspect of object-oriented programming that is called as encapsulation. We discussed what is encapsulation. We discussed what is the need for encapsulation. We discussed what are the different labels of access specifiers that are provided. Then we moved on to abstraction, where we discussed what is the what is abstraction, why do we need abstraction, why does how does abstraction help in the design label, and how does encapsulation help in implementation label. So we discussed all of that. Then we tried to create a distinction between abstraction and encapsulation. Okay, and then we moved on to some of the notable advantages and disadvantages of abstraction and encapsulation. And then we discussed the inheritance, the need for inheritance. Why do we need to why do we need to use inheritance? What are the advantages of inheritance? What is the advantage of reusability? Okay, so now what we'll do is we'll move on to the next striking features of object-oriented programming, that is called as polymorphism. Okay, so polymorphism in Greek basically means the ability to take multiple forms. So here, polymorphism basically means existence of multiple forms of same aspect of interest. So, for an example, I'll give you a very simple correlation. So, for an example, an operator plus can be used to add two numbers, or an operator plus can be used to add three numbers, an operator plus can be used to add four numbers. So, depending upon the type of data that is being provided to the operator plus, it can perform different types of operations. Okay, right? So here what is that is what polymorphism basically refers to. A polymorphism basically refers to existence of multiple forms of same aspect of interest, where what we do is we differentiate between different forms by different by having different number of parameters or different types of parameters, right? Okay, so an operation may exhibit different behavior in different instances. So this is what polymorphism is all about. So the behavior depends on the type of the data being used in the operation. Now the process of making an operator to exhibit different behavior in different instances is known as operator overloading, and the process of making a function exhibit different behavior in different instances is known as function overloading. Now just see here, these are the types of polymorphisms what you can have. You can have one of the polymorphism as operator overloading and one of the polymorphism as function overloading, where in case of operator overloading, you make the operator perform different types of operation depending upon the type of the data that's provided to it. In case of function overloading, you make a function perform different behavior or exhibit different behavior depending upon the type of data provided to it. Now, polymorphism plays a very important role in allowing objects having different internal structure, same external interface. So here just see, whenever we say we are adding up, so it basically means we're performing the operation of addition, but it depends on how many numbers we're adding. So whether we're adding two numbers, whether we're adding three numbers, whether we're adding four numbers. So here you see the external interface remains the same, right? Whereas the internal implementation of different form differs from one another, right? So this means that a general class of operation may be accessed in the same manner, even though specific action associated with each operation may differ. So just see here, this is one of the important advantages of polymorphism. So here, in case of polymorphism, what does it facilitate? Is it facilitates the way how the operations are being it facilitates the way how the operations are being invoked, right? Okay, because as the external interface is common, you need to remember the different interfaces for invoking different different functions. So here we have the same common interface which can be used for performing different operation, and only in the type and the number of parameters that are provided to it, the behavior differs, right? So here you see there are different types of polymorphism. One is called as compile time polymorphism. The other one is called as runtime polymorphism. So compile time polymorphism is also called as static or early binding, and runtime polymorphism is also called as dynamic binding or late binding. So function overloading and operator overloading are kind of compile time polymorphism, whereas function overriding is a type of runtime polymorphism. So we'll come to that whenever we will be discussing polymorphism in detail. So as we have said, dynamic binding. So binding in case of programming is the mechanism of linking the procedure call to the procedure definition. Okay, right? So just see again, I'll repeat it. Binding is the process of linking the function call to the function definition. So whenever a function is being invoked, what we need to do is we need to, or when a function is being called, then what we need to do is we need to link the function call to the function definition. Because say for an example, from a main function, if you're calling a function printf, now printf lies in a header file that's called a stdio.h file that is included in your program, that lies somewhere else, and your main function lies somewhere else. So from main, what we need to do is we need to link the function call to printf. So that means we need to transfer the control to printf. So how do we do it is by providing an access through the address of the function. So as we all know that function name itself is the pointer to the function definition in memory. So what do we do is we link the function call to a specific address where the printf function is located. So that particular process is called as linking. Now linking can be done at compile time, or linking can be done at runtime. So if we know the address of the function that is being called at compile time, so what we do is we link it at compile time, or until unless you do not know the address of the function in compile time, then definitely we need to link it in runtime. Okay. So linking can be done at 2 points in time. Either it can be done at compile time or it can be done at runtime. So dynamic binding basically refers to the act of linking the function call to the function definition at runtime. Okay. So dynamic binding means that the code associated with the given procedure is not known until the time of the call, or it's linked at runtime. So it's associated with polymorphism and inheritance. Okay. So a function call associated with polymorphic reference depends on the dynamic type of the reference, because you see, as we have already said, so there can be multiple there can be multiple existence of multiple form of the same object. So at runtime, what kind of function you're invoking, what depending upon that, what we do is we link the function call to the function definition. So that is called as dynamic binding. So binding can be done either at compile time, or it can be done at runtime. So if you know the address at compile time, you go for compile time binding, and if you do not know the address at compile time, then definitely you need to go for runtime binding. Now let us move on to message passing. So whenever we've discussed till now, whatever we discussed till now, everywhere wherever we discussed object, we have said that objects interact with each other by communicating messages. Why? Because objects do not interact through invocation. This is one of the essential and the most striking features of object-oriented programming, that in case of object-oriented programming, invocation is not allowed. So just see, if you know, if you allow to invoke, then what it basically means that it's you know the address of the data and the address of the function that belongs to a particular object. So if you have an access to the data, and if you have access to the function, then what you can definitely do is you can definitely change the content of the data and change the content of the function, right? Okay. So through indirect reference, what you can do is you can change anything that is there in the computer's memory. So just to prevent that, what they have done is they have introduced a whole new topic that is called as message passing. So through which the objects interact, yet they do not have to invoke each other. So message passing is a mechanism that allows the object to interact with each other, right, without having an invocation relationship. Just see, please listen to me carefully. Here they allow the object to interact with each other without having an invocation relationship. So in case of object-oriented programming consists of a set of objects, and they communicate with each other, and the communication takes place through message passing. So the process of programming in an object-oriented language involves the following basic steps. So this we have already learned: create class definition, creating class that defines objects and their behavior, here, creating objects from the class definition, establishing communication between the objects. So objects communicate with one another by sending and receiving information, much the same way as people pass messages to one another. The concept of message passing makes it easier to talk about building system that directly models or simulates the real world counterpart. So a message from one object is a request for execution of a procedure, and therefore will invoke a function in the receiving object that generates the desired result. Now just see here, this is a very important point that you need to understand. So whenever two objects interact, so let us consider there are two objects A and B interacting with each other. So whenever two objects A and B interact with each other, A sends a message to B, because let us consider that A wants an operation to be performed by B. So what A provides is A provides a message wherein A provides in the message the data that is to be used and the operation that is to be performed, right? So A provides to B the act that B has to perform using what data, right? Okay, so when B receives it, the object B decodes the message, separates the message into data and function, and then B invokes its own message. Now just see here, A is not invoking B's behavior, right? Okay, which happens in case of procedure-oriented programming or function-oriented programming. In case of function-oriented programming, a function A invokes a function B. But here, an object A communicates message to B, then B invokes its own behavior. So in this manner, what happens is that the way how the implementation of B's function and data is done is being abstracted from A, or it's not known to A, right? Okay? So this is one of the important striking characteristics of object-oriented programming. So a message from an object is a request for execution of a procedure. So it's a request, it's not an invocation, and therefore will invoke a procedure in the receiving object. Just see, it will invoke a function in the receiving object. So who invokes it? The receiving object invokes it, that generates the desired result. Okay. So this is the way how or that this is the importance of message passing, right? Okay. So here, by not allowing an object to invoke another object, what we are doing is we're preserving the integrity of the data. We're not only preserving the integrity of the data, we're preserving the integrity of the methods as well, right? Now let us try to sum up the chapter, and let us try to identify some of the benefits of object-oriented programming. Right. Okay. So object-oriented programming definitely ensures increased productivity. Right. The generation of better quality software system, and reduction in the maintenance cost. Right. Okay. Because you see the concepts like polymorphism, inheritance. Right. So it allows for reusability, thus decreasing the overall time of implementation, resulting in increase of the productivity, right? Okay, so since you are preserving the integrity of the data and methods both, what you're doing is you are providing a better quality software, right? Okay, and since the entire object-oriented software development paradigm is based on identifying objects and then attributes and then behaviors and then relationships, the overall maintenance cost will be very low, right? Okay? So as we have already said, through inheritance, what we can do is we can eliminate redundant code, extend the use of the existing classes. So what we can do is we can define a new class from the existing class, and then use it as per our requirement. So can we build programs for standard working modules that communicate with one another rather than having to start writing the code from scratch. So what we can do is we can use the existing code and create a new program. So this leads to saving of development time and higher productivity. In turn, it will increase the profitability of the organization as well, right? So the principle of data hiding helps the programmer to build secure programs that can not be invaded by codes in other parts of the program. So you see, this is what we have learned. It preserves the integrity of the data and integrity of the methods, right? Okay, so it is possible to have multiple instances of an object to coexist without any interference, right? So it is easy to partition the work into project based on objects. Now You see, so the next advantage you can the data centric approach enables us to capture more details of the model model can for the implementational label or implementation label. Object notice system can be easily upgraded from smaller to larger system. Message passing techniques for communication between objects makes to interface descriptions with external system much more simpler. Software complexity can be easily managed. Now, see, these are the few of the notable advantages. So there are several other advantages of object-oriented or benefits of object-oriented programming. Now, out of this, there are some of the important notable advantages that you need to remember. That is, increase in the productivity, right? Again, use of inheritance, use of polymorphism, okay, right? Use of abstraction, use of encapsulation, right? Again, creating a very close resemblance with the real world situation by having objects that resembles the real world entity. So here what we do is, in case of object oriented paradigm, as we've already discussed, emphasis given on data rather than on procedure. So it helps in whenever emphasis given more on data, then it helps us to extract more information about the system that will ease implementation, right? Again, so upgradation from a smaller system to a larger system is very easy. Message passing ensures that invocation is not done. So if invocation is not done, then there can be no mechanism established for altering the data value and the nature of the behavior and management of software complexity. So you see, these are a few of the notable advantages that object-oriented programming platform has. So what you can do is you can refer to other literatures as well to find out the other benefits of object-oriented programming. So in today's class, what we've done is we have been through polymorphism, right? Okay, we've been through what are different types of polymorphism, what is the use of polymorphism, right? Again, we've been through what is binding, right? We've been through what is static binding, we've been through what is dynamic binding, and what is the need for dynamic binding. We've been through that. And then we have discussed message passing, the basic essence of message passing. Why do we need it, right? Again, how can invocation can be avoided by message passing, right? And then we discuss some of the notable benefits of object-oriented programming. So this basically ends the first chapter. Thank you very much. Have a good day.